Ladies and gentlemen, this is an instructional video on drawing a line of best fit and writing the equation to the line of best fit. Okay, before you get too far in this instructional video, make sure you grab a note guide, your ruler or a straight edge, and a pencil. Okay, find the spot in the note guide where you need to jot down the definition for the line of best fit. So the line of best fit is a straight line drawn through the center of a group of data points plotted on a scatter plot. All right, so what I want to point out to you on this scatter plot right here is the orange line is the line of best fit. I'd also like to point out that the orange line cuts the blue data points roughly in half. So about half the data is above the orange line and half is below. And I'd also like to point out that the line of best fit is a straight line drawn in with a ruler or a straight edge. Okay, go ahead and press pause and jot down the steps for drawing a line of best fit. Okay, the first step is to circle the data points. Your circle might look a little bit more like an oval, and that's okay. Step 2, use a ruler to draw a straight line. So about half the data points are above and half the data points are below the line of best fit. Your data or your fitted line or the line of best fit, you can use either one of those terms, should be within your circle or your oval from step 1. Okay, we'll do an example. I'll show you what we mean by that. So find your scatter plot on your note guide. All right, go ahead and let's circle or draw an oval around the line of best fit. Do you notice how that oval kind of holds in all the data points or the dots that are on the scatter plot? Okay, now you're going to grab a straight edge and you're going to draw in the line of best fit using a straight edge. You're going to try to cut the data about in half. You're also going to want to cut the oval in half. Okay, so my line of best fit could look something like this. Let's see here. It looks to me like I've got 1, 2, 3, 4, 5, 6 points above the line and about 5 points below the line. So I am going to call that line of best fit good. I divided the oval in half and the data is roughly cut in half. So I think that line of best fit looks pretty good. Okay, now that you drew the line of best fit, now we have to write the equation for the line of best fit. So your first job is to pick 2 ordered pairs on the line. They do not need to be the points, the scatter plot points, or the dots on your scatter plot. They just need to be 2 points on the line. All right, your second step. Calculate the slope using 2 ordered pairs. So you're going to pick the 2 ordered pairs that are on the line. You're going to plug them into the slope formula that we've been using since chapter 3. So we're going to do slope equals y sub 2 minus y sub 1 all over or divided by x sub 2 minus x sub 1. Once we have the slope, we're going to calculate the y-intercept using an ordered pair and the slope that we just calculated by plugging them into y equals mx plus b. And then our last step is to calculate the slope in the y-intercept, or to substitute the slope in the y-intercept into the equation y equals mx plus b. Okay, so here is our line of best fit. If I go back to it, now I need to pick 2 points that are on the line, and I want to be really specific and pick good points. So for example, if you look at my line way up here, I would not pick this point because it cuts through like in the middle of the lines. I can't say exactly what it is. So I want to pick an ordered pair that's on the line, and I can tell you exactly what it is. So right now when I'm looking at my line, I like that point right there. So I'm going to use that point. That point is 2, 4. I know it's 2, 4 because I go right 2 and up 1, 2, 3, 4. Now here's the deal, guys. You should be picking different points than I am, because I'm sure you didn't draw your line exactly in the same spot as I did. So just pick 2 points that are on your line. Okay, as I continue up the line, it looks like this scatter plot point is also a point on my line. Doesn't always work out like that. Sometimes it's 2 points that you just have to find that are on the line. So this ordered pair is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. So 6, 7. Now, you guys might find that you have 2 completely different ordered pairs than I do. That's kind of how it should work out. We still will come up with an answer that's pretty close. We won't be exact, that's okay, but we should be pretty close. Okay, I just found a spot and I rewrote my ordered pairs. I'm going to label them x sub 1, y sub 1, x sub 2, y sub 2. And I really want to stress, you guys, you probably have 2 different ordered pairs than I do, and that's okay. Okay, first one to calculate slope. All right, so remember that's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, so I'm going to substitute my values in. So I'm going to do 7 minus 4 over 6 minus 2. When I simplify that, I'm going to get 3 over 4. Okay, you guys, listen. In this unit, it's okay to write your slope as a decimal. Did you hear that? That's crazy different than what we've done before. It's okay because we're writing the equation of a line. We're not going to be using the slope to graph it. So it's okay. And it might be easier for you to input into your calculator if you use the decimal equivalent. So if your ordered pairs were different than mine, you should notice that your slope with your 2 ordered pairs should be really close to 0.75 or 75/100ths. All right, so the next step to calculate B is I have to pick an ordered pair and I have to pick the slope. And I'm going to substitute those values into y equals mx plus b. You can pick either ordered pair. I'm going to pick the first one. No reason, just because it's there and it's first. So I'm going to substitute y, 4 in for y. So 4 equals, the slope is 0.75 or 75/100ths, or if you'd rather deal with fractions, you can do 3/4, times x plus b. Okay, so now I'm going to simplify. 4 equals 0.75 times 2 is 1.5 plus b. I'm going to solve for b by subtracting by 1.5 on both sides. What I'm going to figure out here is that b, my y-intercept, is 2.5. Okay? Now my last step is to take my m and my b and substitute it back into y equals mx plus b. So the equation of my line should be y equals 0.75x plus 2.5. Okay, again, what I want to point out is your slope might not be the same as mine. It probably won't, but it should be close. And your y-intercept probably isn't 2.5, but it should be pretty close. All right, you guys, I went back to my graph with my equation, so you can see that right here. And when I look at my graph, I'm looking to see if it matches this information. So I said the y-intercept was 2.5. Check this out, you guys. If I look where the line crosses the y-axis, it looks like it crosses pretty close to 2.5. That means I probably did a pretty good job calculating my y-intercept. And my slope is 0.75, or remember that was equal to 3/4. So if I pick my original starting point, I can just check my work. 2, 4 was my original point. If I rise 3, 1, 2, 3, and run 4, 1, 2, 3, 4, I'm back at a point on the line. So that's an easy way for me to go back and double check to see if my equation for the line of best fit is pretty close. All right, ladies and gentlemen, that's it. Go ahead and complete the checkpoint question, check in with your teacher, and earn your homework. Good luck.